Hello friends, now in this video we will start the new chapter, real numbers. In real numbers you will learn properties of rational numbers, properties of irrational numbers, sets, comparison of quadratic sets, operations on quadratic sets, and last the rationalization of quadratic sets. Now in this video, I will explain all solved example and all examples given in exercise 2.1 in a very simple language. Now let us start. In previous classes, we have learned about natural numbers, integers and real numbers. Here n is equals to the set of natural number 1, 2, 3, 4 up to infinity. W is equals to set of whole number 0, 1, 2, 3, 4 up to infinity. I is equals to set of integers, that is 0, 1, 2, 3 up to infinity, minus 1, minus 2, minus 3 up to minus infinity. And Q, that is a set of a rational number. It is of the form P upon Q, where P comma Q belongs to set of integers and Q is not equals to 0. And next, R is equals to set of real numbers. Okay. Now see this, the subset relation between all these sets. That is, set of natural number is a subset of set of whole number, and so set of whole number is a set of integers, and set of integers is set of rational numbers. And all these sets are the subsets of set of real numbers. Now order relation on a rational number. Okay. That is, here P upon Q and R upon S are rational numbers, where Q and S both are positive. It means that Q is greater than 0, S is greater than 0. First, if the cross multiplication, that is a P into S and Q into R, both are equal, then the given rational numbers are equal. It means that P upon Q is equals to R upon S. Second, if P into S is greater than Q into R, then the rational number P upon Q is greater than R upon S. And if P into S is less than Q into R, then the rational number P upon Q is less than R upon S. Now, properties of rational numbers. If ABC are rational numbers, then what are the properties? The first is a commutative property for the addition and multiplication. If you take any two rational numbers and if you add it like this, a plus b, then their addition is equals to b plus a. Means what? 2 plus 3 is 5 and 3 plus 2 is also 5. Okay. And therefore addition is a commutative. What about the multiplication? That is a 2 into 3. You will get 6 and that's equals to 3 into 2. It means that the multiplication is a commutative for rational numbers. Next property, that is a associative property. Here, if ABC are the rational numbers and if we add first a plus b and then add plus c, and that's equals to b plus c plus a, and this property is called the property of associative for rational numbers. Next, multiplication is also associative for it. That is a into, in bracket, b into c, and that's equals to a into b. After their multiplication, if you multiplied with by c, then again both sides are equal, and hence multiplication is associative for the rational numbers a, b, c. Okay. Identity. Now there are two identities. One is additive identity. If we add 0 to any rational number, or rational number is added 0, then the given number is a rational number. It means that a plus 0 is equals to 0 plus a is equals to a, and multiplicative identity. If we multiplied a into 1 or 1 into a, then you will have a. That is a 5 into 1 is equals to 1 into 5 is equals to 5. Or for example here, 5 plus 0 is equals to 0 plus 5 is equals to 5. Okay. And here we say that 0 is a additive identity and 1 is multiplicative identity. These are properties of a rational number for the addition and the multiplication. Okay. Next, inverse property. That is, if we add minus a to plus a, then you will have here 0. Therefore, additive inverse of a is a minus a. And if we multiply a by 1 upon a, then that's multiplication is equals to 1. And therefore, 1 upon a is called multiplicative inverse of a. That is a 5 into 1 upon 5. That's equals to 1. Therefore, multiplicative inverse of 5 is 1 upon 5. Okay. And additive inverse of 5 is minus 5. Additive inverse of minus 3 is plus 3. Okay. Now next, decimal form of any rational number is either terminating or non-terminating recurring type. Now see this here, terminating type. Here the division ends. If we divide 2 by 5 and then you will have 0.4. Okay, this is terminating type. Next, minus 7 upon 64 and that's equals to minus 0.109375. Again, this is a terminating type. यामध्ये डिव्हिजन हा एंड होत असतो, इथे रिमाइंडर आपल्याला 0 मिळत असतो, and therefore we say this type is a terminating type. Next, 101 upon 8 and that's equals to 12.625. Here division ends and this is called the terminating type rational numbers. Okay. Now next, non-terminating recurring type. या टाईपच्या रॅशनल नंबर मध्ये आपण जेव्हा डिव्हिजन देत असतो तर ते रिकरिंग असतं. ओके, that is the here the number 2 recurring here, and hence we will write here 17 upon 36 is equals to 0.472 and a raised to dot. Okay, these are the non-terminating recurring type rational numbers. Okay, 33 upon 26 and that's equals to again the group of the digits, that is a 692307 is again repeating here, and hence we write here 1.2692307 and raised to bar. Next, 56 upon 37 and if we divide it, then the group of the numbers, that is a 513 513 513 is recurring there, and hence we write here 1.513 raised to bar. Okay, and these are decimal form of a rational number which are terminating and non-terminating recurring type. Okay. Now next, to express recurring decimal in P upon Q form. Now this is interesting. First example, express recurring decimal 0.777 dash dash in P upon Q form. Now here the digit 7 is repeating here, therefore we will write here let x is equals to 0.77 and that's equals to 0.7 raised to dot. Now here single digit is repeating here, therefore we will multiply to the both sides, that is a x is equals to 0.77 by 10 to the both sides. Okay, therefore 10 into x you will get here 10x, and if you multiply 0.777 dash dash to by 10, then we will get here 7.777 dash dash, that is we will shift this decimal point to the right hand side as we are multiplying by the 10, and hence you will get here 7.777 dash dash, and again it can be written as 7.7 raised to dot, and hence here we have x is equals to 0.7 raised to dot, and here 10x is equals to 7.7 raised to dot. Now next, subtract this x from the 10x, that is you will get here 10x minus x, that is subtraction of left hand side. 10x minus x is 9x, 7.7 dot minus 0.7 dot, then this 0.7 dot 7 dot will get cancelled. Okay, then this subtraction you will get here 7. Therefore, x is equals to 7 upon 9, and this is in P upon Q form, and therefore we can express 0.777 dash dash in P upon Q form. Now, next example. Express recurring decimal, that is 7.529529 in P upon Q form. Now again here let x is equals to 7.529529. Now the group of the digits, that is the 529 is repeating here, recurring here. Therefore we will write here 7.529 raised to bar. Okay. Now here 3 digits are repeating, and hence we will multiply to this expression, that is the x is equals to 7.529529 by 1000. Okay. And therefore x into 1000, then you will get here 1000x, and if you multiply 7.529529 by 1000, then you will get here 7529.529529. Okay, and again this can be written as like this, that is 7529.529 raised to bar. Okay, now subtract this x from 1000x, then you will get here 1000x minus x. Similarly to the right hand side, 7529.529 raised to bar minus 7.529 raised to bar. Now these two terms will get cancelled, that is a 7529 minus 7, then you will get here 7522.0. 1000x minus x, you will get here 999x, and hence x is equals to 7522 upon 999, and this is in the form P upon Q, and hence we can express 7.529529 dash dash in P upon Q form, that is 7522 upon 999. This is the answer. Next, remember this. Okay. Note the number of recurring digit after decimal point in the given rational number. Accordingly, multiply it by 10 if single digit is repeating there. If the group of 2 digits is repeating there, then multiply it with by 100. If 3 digits are repeating, then multiply it with by 1000. Okay, that is in example, that is a 2.3 raised to dot. Here digit 3 is only recurring digit after decimal point, and hence to convert 2.3 raised to dot, that is a digit in P upon Q form, multiplied 2.3 raised to dot by 10, and in 1.24 raised to bar. Here the digit 2 and 4 both are recurring, therefore multiply 1.24 raised to bar by 100, and in 1.513 raised to bar, here the digit 513 are recurring, so multiply 1.513 raised to bar by 1000. Okay. Next, notice the prime factors of denominator of rational number. If the prime factors are 2 or 5 only, then its a decimal expansion is a terminating. And if the prime factors are other than 2 or 5 also, then its decimal expansion is non-terminating and recurring. Okay. Remember this. Now we'll start the practice set 2.1. First example. Classify the decimal form of the given rational numbers into terminating and non-terminating recurring type. First example, 13 upon 5. Now here 13 upon 5 is a terminating type because its denominator is prime factor of 5. Okay, and therefore this is terminating type. Next, 2 upon 11. 2 upon 11 is a non-terminating recurring type because its denominator is other than prime factors 2 or 5. Now the same rule is here. Okay. Next, 29 upon 16 is a terminating type because its denominator is a prime factor of 2. Again, I am repeating your rule. Next, 17 upon 125 is a terminating type because its denominator is a prime factors of 5. 11 upon 6 is non-terminating recurring type because its denominators are other than prime factors 2 or 5. Okay. Next, write the following rational numbers in decimal form. First is 127 upon 200. Now we'll divide 127 by 200. Now the first division is a division of 0. That is 127 is a less than 200. Therefore, we'll first give the division of the 0. 0 into 200, then you will get 0. Subtraction 127. Then take the decimal point 10 on 127. The number will become 1270. Now the division of the 6, that is a 200 into 6. Then you will get here 1200. Subtraction 70. Again one more 0 on 70. The number will become 700. 200 into 3. Then you will get here 600. 700 minus 600. You will get 100. Again 10. That number will become 1000. Again 200 into 5. You will get 1000. Okay, that's subtraction, and the remainder is 0. Okay, again this is the terminating type division because the denominator have the prime factors 2 or 5. Okay, and hence we will write here 127 upon 200 is equals to 0.635. Next, 25 upon 99. Again 25 is a less number than 99. The division of the 0. 0 into 99, you will get it 0. Subtraction, again 25. Give the decimal point, one more 0 on 25. Then you will get here 250. 99 into 2, you will get here 198. Okay. 1, that is a 250 minus 198. Then you will get 52. Again one more 0. 520 and 520. Therefore 99 into 5. Then you will get here 495. Then subtraction, you will get 25. Okay, here the digit 25 is again repeating here. Okay, and now this is recurring type, and we can write here 25 upon 99 is equals to 0.25 raised to bar. Now next example, 23 upon 7. Now first division is a 7 3s are 21. 23 minus 21, you will get here 2. Again decimal point. 7 2s are 14. Okay. 20 minus 14, then you will get 6. Okay. Again next. 7 into 8, you will get here 56. Okay. Next. 40. 7 into 5, you will get here 35. Again 40 minus 35, you will get here 5. Then 50, 7 into 7, you will get here 49. 50 minus 49, you will get 1. Next 7 into 1, you will get here 10 minus 7, that is equals to 3. Okay. Next 7 into 4, 28. 30 minus 28, then you will get here 2. Now again the recurring type occurs here, that is 20 and 20, and hence we can write here 23 upon 7, that's equals to 3.285714 raised to bar. Okay. Now next example. Write the following rational number again in the decimal form. First is the division of 0. 5 into 0 is 0. 4 minus 0. Then the decimal point 40. 5 z's are 40. Okay. And hence 40 minus 40, the remainder is 0. Therefore 5 by 4 is equals to 0.8. Next 17 upon 8. Now here we will divide here. 8's 2's are 16. 17 minus 16, then you will get here 1. Again decimal point. Then 8 into 1, then you will get here 8. That is a 10 minus 8, 2. Okay. Then 8 2's are 16. 20 minus 16, you will get here 4. Okay. Then 40. 8's 5 are 40. And hence the remainder is again here 0. Therefore we can express 17 upon 8 in decimal form. This is terminating type. 17 upon 8 is equals to 2.125. Now next, write the following rational numbers in P upon Q form, that is 0.6 raised to dot. Now the solution, let x is equals to 0.666, that is the digit is single digit is repeating here, therefore we will multiply. 6 is only recurring digit, so multiply both sides by 10. Therefore 10x is equals to 10 into 0.6666. Then you will get here 10x is equals to 6.6. This is expression number 2. Now the subtraction, equation 2 minus equation 1 means what? 10x minus x, you will get here 9x, and 6.6666 minus 0.666, and their subtraction, that is a 9x is equals to 6, and hence x is equals to 6 upon 9, and that is equals to 2 by 3. And hence we can express 0.6 raised to dot, that is equals to 2 upon 3. इथे डॉट पाहिजे होता, ह्या दोन्ही 6 raised to, okay, it's a printing mistake. Therefore the answer is 0.6 raised to dot in decimal form, that's equals to 2 upon 3. Now next example, 0.37 raised to bar. Here let x is equals to 0.37 raised to bar. This is the equation number 1. Here 3 and 6 are the two recurring digits. So multiply both sides by 100. 100 into x, you will get here 100x. And to the right hand side, 100 into 0.3737 dash dash. After multiplication, you will get here 100x is equals to 37.37 raised to bar. This is expression number 2. Okay. Now equation 2 minus equation 1 means what? 100x minus x is equals to 37.37 raised to bar minus 0.37 raised to bar is here, and here 100x minus x, you will get here 99x. 37.37 raised to bar minus 0.37 raised to bar, these two terms will get cancelled, and hence you will get here x is equals to 37 upon 99, and hence we have expressed 0.37 raised to bar is equals to 37 upon 99. Now next, 3.17. Now we let x is equals to 3.17 raised to bar. Here 1 and 7 are the two recurring digits. So multiply both sides by 100. 100 into x is equals to 3.1770 dash dash into 100. Okay, after multiplication you will get here 100x is equals to 317.17 raised to bar. This is expression number 2. Next, equation 1 minus equation 2 means what? 100x minus x. You will get here 99x, and 317.17 raised to bar minus 3.17 raised to bar. Here 100x minus x, you will get here 99x. 317.17 raised to bar minus 3.17 raised to bar. Their subtraction is a 314, and therefore x is equals to 314 upon 99. Okay, and hence 3.17 raised to bar is equals to 314 upon 99. Next, 15.89 raised to bar. Again here let x is equals to 15.89 raised to bar. Here 8 and 9 are the two recurring digits. So multiply both sides by 100. 100 into x is equals to 100 into 15.8989 dash dash. Okay, then you will get here 100x is equals to 1589.89 raised to bar. This is expression number 2. Again same thing is here, equation 2 minus equation 1, 100x minus x. Okay, then you will get here 99, and 1589.89 raised to bar minus 15.89 raised to bar, then you will get here 1574. Okay, and therefore x is equals to 1574 upon 99, and hence the answer is 15.89 raised to bar is equals to 1574 upon 99. Next, 2.514 raised to bar, let x is equals to 2.514 raised to bar. Here 5, 1 and 4 are the three recurring digits. So multiply both sides by 1000. 1000 into x is equals to 1000 into 2.514514 dash dash, and here after multiplication you will get 1000x is equals to 2514.514 raised to bar. This is expression number 2. Next, equation 2 minus equation 1, that is 1000x minus x. Okay, and to the right hand side 2514.514 raised to bar minus 2.514 raised to bar, and after subtraction you will get here 999x is equals to 2512, and hence x is equals to 2512 upon 99. Okay, and again this is the answer, 2.514 raised to bar is equals to 2512 upon 99. And in this way we have completed the first exercise 2.1. Now we'll see in the next video. Till then, goodbye.